Welcome everyone, and thank you for joining us today. My name is Geir Engdahl, and I am a co-founder and Chief Technology Officer of Cognite. I have the pleasure of welcoming you all to this Cognite product tour, a Data Contextualization Masterclass. At Cognite, we have always believed in the importance of data contextualization. Cognite was founded on the idea of simple access to complex industrial data. We saw a need in industrial environments where data was siloed, difficult to understand, and very rarely used to generate any real business value. Since our founding, we've helped customers all over the world to bring context to their data so that they can use it to optimize their production, deliver safe and sustainable operations, and make high-quality AI-powered business decisions. If you're tuning in, then we know you're one of the many industrial leaders who recognize the importance of contextualization. You're eager to learn how to automatically contextualize and model OT, IT, and engineering data to accelerate digitalization and build solutions at scale. The need for contextualized data to deliver business use cases at scale is becoming well understood. Now, with the potential of generative AI in industry, the importance of being able to contextualize data has become paramount in delivering generative AI capabilities that will maximize the business impact. We have recently been discussing this topic in depth on our Generative AI for Industry World Tour for industry executives. At these events, Cogniters, including Jason Shern, have explained why you need contextualization to get the most out of your generative AI investments. In today's masterclass, we'll show you how to onboard data from OT, IT, and engineering sources and populate the industrial knowledge graph, or digital twin, if you will, through AI-driven contextualization. We'll then leverage our contextualized digital twin to solve a real-world valuable business problem with the help of generative AI. Before we begin the main event, I would like to draw your attention to some housekeeping matters. Today, we will cover about 60 minutes of product demonstrations. I will be joined by my colleagues Pete Kramer and Andrea Pastinaro Oprea, who will be guiding you through this masterclass. This is a recorded event, and it will be made available on demand afterwards. Questions and follow-up are always welcome on our customer community, which is Cognite Hub, which you can find at hub.cognite.com. And without further ado, let's start Cognite's masterclass on data contextualization. Before we dive into complexities, let's start with the important basics. What is contextualization? To put it simply, contextualization is the process of identifying and representing relationships between data to mirror the relationships that exist between data elements in the physical world. This is what you can remember, write down, and tell to your colleagues, friends, and families when they ask you this same question. Data contextualization is about creating relationships across previously siloed data sources and types like time series, images, asset hierarchies, events, 3D models, etc., etc. So experts can easily access information and analyze the data. Ultimately, contextualization produces a richer data model that is greater than the sum of its source systems. But what happens when industry experts don't have access to trustworthy contextualized data? Well, people still need context to understand what's happening with their production process or a particular piece of equipment. When a subject matter expert must painstakingly and manually dig through many source systems to gain a sufficient understanding of their industrial reality, we refer to this workflow as human contextualization. It is this lack of simple access to complex industrial data that results in the well-known challenge facing industrial organizations, that their people are spending the vast majority of their time gathering data, manually adding context to understand their industrial reality, rather than building or using solutions that generate business value. Contextualization turns this ratio around. It makes the process of finding data orders of magnitude simpler and more efficient, ensuring people can spend their time and industrial expertise where it matters the most. Contextualized data also provides the industrial data backbone required to get the most out of investments in artificial intelligence. The reality is, for every one person who speaks code, there are 100 others who do not. Delivering business impact with data and analytics cannot require upskilling this 100-fold audience. It has to be about making the data speak their language. It's about making data and analytics speak human. You all have heard about data democratization. What we get with contextualization is simple access to our complex industrial data. We do this with generative AI-powered co-pilot experiences that are intuitive, easily accessible, and, of course, collaborative. We bring the data consumption experience to the human user level, in their language, on their terms. But keep in mind that generative AI is no silver bullet. When it comes to generative AI, context means everything. To talk to data like we talk with ChatGPT and generate valuable, actionable insights, we need data that is contextualized in a deterministic, structured knowledge graph. Solving the industrial data problem coincides with solving the AI problem. Data must first speak AI before AI can speak with you about your industrial reality. Large language models from ChatGPT, DALL-E, and more have exposed us to the incredible generative capabilities of this latest advancement in deep learning AI. However, the generative part of LLMs can be both a blessing and a curse. There's another side to large language models that is often overlooked amidst the generative excitement. Contrary to what it might seem, LLMs don't read or search text. They convert words and data into numeric representations and use math to make comparisons and infer semantic or meaning-driven relationships. We call these embeddings. It is these embeddings that are stored or indexed and provided to ChatGPT as the necessary context to solve a problem or query. Without sufficient context, we see a tendency for these models to hallucinate, with responses that seem convincing but are actually inaccurate. For generative AI, the old adage of garbage in, garbage out applies. This is why simply plugging your data lake into ChatGPT will give unreliable and untrustworthy results. This is what we refer to as the industrial AI problem. Industrial data is a complex mix of unstructured content in the form of piping and instrumentation drawings, technical documentation, images, video, and reports, as well as structured content from enterprise systems and time series sensor data. Context is not inherent in the data itself. This is where and why contextualization comes as a means to train an LLM on your industrial data. When harnessed and provided with rich, contextualized industrial data, it is possible to use the reasoning engine of LLMs to generate deterministic or fact-based answers to natural language prompts. Retrieval Augmented Generation, or RAG, is a design pattern we can use with large language models to provide contextualized industrial data directly to the LLM as specific content to use when formulating a response. This approach allows us to utilize the reasoning engine of LLMs to provide deterministic answers based on the specific inputs we provide, rather than relying on the generative engine to create a probabilistic response based on existing public information. In short, this allows generative AI to understand your industrial data. In the past, people were forced to speak data in order to gain actionable industrial insight. Then, we progressed to make industrial data speak human. Complex industrial data can be liberated, contextualized, and simply made available to the humans and machines who need them. Going forward, we must ensure that your AI investments speak to your people about your industrial data. With a strong data foundation and retrieval-augmented generation, we can get deterministic answers to natural language prompts by explicitly providing the inputs that LLMs should use when formulating a response. Codification of industrial data across the wide variety of structured and unstructured data types will drive the next generation of industrial data operations powered by AI. On June 15th, we announced Cognite AI, the first of its kind generative AI accelerator for industrial data and value realization. This provides asset-heavy organizations with a solution to the industrial data and AI problems. Cognite Data Fusion now integrates generative AI into every aspect of the product experience. Generative AI is enhancing data modeling and contextualization to further automate the creation and maintenance of the industrial knowledge graph. This knowledge graph codifies the rich semantic relationships across industrial data, making it possible for generative AI to revolutionize the end-user experience by providing deterministic answers and insights to natural language prompts. With an innovative architecture, Cognite AI couples generative AI and its LLMs with Cognite Data Fusion specific data modeling and retrieval-augmented generation capabilities. Combined, Cognite AI uniquely augments the ability of generic-purpose LLMs to retrieve data from customers' private sources to generate more purposeful, accurate, and sophisticated outputs based on an industrial organization's private industrial data within their secure and protected tenants. This approach eliminates data leakage, keeps data trusted and in your control, and minimizes hallucinations. Without further ado, I'll hand it off to Pete Kramer, who will guide you through how to contextualize data by building and populating the industrial knowledge graph with Cognite Data Fusion.
Hello everyone, my name is Pete Kramer and I'm an engineering manager here at Cognite. During today's masterclass, I'll be guiding you through the process of building and populating the industrial knowledge graph. There are 5 types of contextualization we'll be discussing today. First, entity matching. This is for matching data or entities coming from different sources to their appropriate counterparts. It's easy to match a few dozen equipment tags to their corresponding time series trends one by one, but when you are dealing with hundreds of thousands of tags and millions of trends in a particular plant, that's where entity matching is a valuable tool. Second, 3D models and point clouds. 3D models and point clouds provide a great frame of reference for the human mind and is both a way to easily find data using spatial reference and a way to visualize data in a manner that is instantly understandable. In order to make this model interactive, we need to contextualize it, i.e., link the different shapes and objects to the relevant nodes in the industrial knowledge graph. Third, engineering diagram and document parsing. Engineering drawings need to be contextualized to become truly valuable and integrated into the industrial knowledge graph. This form of contextualization is about extracting information from engineering diagrams and documents, for example, PIDs and equipment specs, to create fully interactive diagrams that contain connections to all corresponding equipment tags and related documents. Whether they are captured with cameras, drones, or on a mobile phone, images and video data contains valuable information about the state of a facility over time. This form of contextualization is about enriching these files with computer vision by detecting objects, equipment tags, gauges, spills, and more. Last but certainly not least, we have data modeling. A data model organizes data objects and standardizes the properties of real-world entities and how they relate to one another. But before we can start to contextualize data, we obviously need to start by liberating the data from its siloed source systems. The very first step is actually bringing data into Cognite Data Fusion. You have various options, so-called extractors. Extractors allow you to get your data out of a source system into CDF. As an example, you can easily export from orders from SAP, time series from OPC UA, or robotics data. Or you can also build a custom extractor connected to any relevant data source. So what is entity matching? Entity matching is basically a Swiss Army knife for creating relationships for data in different sources. It allows you to fuzzy match any kind of string data properties, such as equipment names, descriptions, or metadata. You can use it to contextualize basically everything in CDF. For example, you can match an asset to the relevant time series, or you can match the assets with their particular nodes in a 3D model. We have our equipment tags in Cognite Data Fusion, but we don't have our 3D models yet. Let's upload it. As you can see, we have a few different options. We have a quick match for one-time batch jobs. Great if you have a data dump and want to match, for example, assets to time series or work order events to assets. Entity matching pipelines is for continuous matching workflows, where you need to rerun a matching on new data that is coming into CDF on a continuous basis. For example, if a new equipment is installed, your asset hierarchy might change and you might get a new time series for new sensors that have been installed on site. Entity matching pipelines allow you to contextualize those automatically as your industrial facility grows and changes over time. Finally, we have 3D model matching. This is a specialized entity matching flow to match nodes in a 3D model to assets. In order to make this model interactive, we need to contextualize it. That means linking the different 3D shapes to the relevant nodes in the industrial knowledge graph. This is actually a form of entity matching that also works on other metadata by looking for patterns in text. We simply select the 3D model to map and then the data set we want to map it to. We can give the model some hints as to what metadata to look for mappings in, and then the AI contextualization starts predicting matches. In order to build trust in the data, we can view the suggested matches and adjust our confidence threshold for accepting matches. It is the contextualization that makes it possible to click on an object in 3D and get the associated data or jump from an equipment reference in the document to that equipment in 3D. Instead of using the UI, you can actually also do all of what we have shown in the SDK, which gives you much more power on what you can do with CDF. We can do this actually inside of CDF in a Jupyter notebook that is interactive and that allows you an easy login flow to interact with your data. Industrial organizations have millions of diagrams and documents that contain critical information about industrial processes, systems, and equipment. Without technology to automate this process, people are forced to manually dig for information across systems and static PDF files like a needle in a haystack. And of course, they or their colleagues need to repeat this process each and every time they need the same or new information. Cognite Data Fusion provides the means to automate the process of contextualizing engineering diagrams at scale and customize the algorithm to fit the format of the files you're working with. We simply select the set of documents that have already been extracted and onboarded to Cognite Data Fusion as the diagrams we want to parse. The algorithm will also detect references between different documents, and so we select a set of documents that can potentially be linked to. In this case, they are the same. And we select the set of equipment to potentially link to as well. We have several options to choose from here, potentially increasing the accuracy. When we run the model, computer vision object detection is used to find important symbols, and OCR, optical character recognition, is used to read the text in the drawings. Entity matching is then applied to map the detected symbols and text in the drawings to assets in the appropriate data model. When the contextualization algorithm is done, we can preview and validate what it is doing. All the highlighted colored regions here represent matches to assets or references to other documents. We can also manually add more annotations if the algorithm misses some assets. We will typically run the engineering diagram parsing as part of the automated flow as documents are ingested. While all this diagram parsing and contextualization may seem complex, it is key to offer the user experience you are about to see later in this masterclass. Cameras are cheap sensors and are increasingly being used to collect images and videos in heavy asset industry during, for instance, inspection and maintenance routines. However, utilizing this data fully remains a challenge. Today, the collected data is typically spread across various legacy systems, which severely reduced the value and usability of the data, making the collected data extremely short-lived. With Cognite Data Fusion, you can securely store and control access to the data in a central location and unlock the value of the historical backlog. These services exist both as API and SDKs and can be used in automated pipelines for analyzing imagery data with the power of AI. As you can see here, we have an image already in Cognite Data Fusion, and we want to use the built-in service for analyzing this data to see what we can extract from it. In fact, this is a picture of our CTO, Geir, who you have already met in this masterclass, when he visited an offshore installation. We can see that there are several annotations that have been identified for this picture. This provides a quick summary of the detections. We can also view the image in full size and see that some objects have been detected. We see here, for example, that Geir is identified as a person who has a helmet, and both of these results have a high confidence level. I can approve or reject these detections by clicking on True to verify them. You can also see that we have some text detections and even an asset tag that has been detected. This is what will make it easier for subject matter experts to find and use this data to gain an up-to-date real-world view of their industrial reality. A data model enables users to customize the shape, structure, and their expectation of data. It plays a crucial part in building solutions like data science models, mobile, and web apps. But it is also the core of an ontology, knowledge graphs, or industry standard. In the industrial world, there are 3 categories of data model, each serving different purposes with different levels of complexity. First, source data models. Source data models reflect how the data was represented in the original application or source system it is originally coming from. Examples of this type of data model could be any data warehouse or source, for example SAP, work orders, DMC alerts. Second, domain data models, ontologies. These may be based on industry standards like TIFOS, CNC, or ISA 95. There will be multiple domain data models working closely with each other, contextualized to reference the same underlying data. Third, solution data models. These are the most iterative of the types of data models. They represent the expectations of data for a use case, application, dashboard, or other solution. These data models will reference and connect to data in data from all other source, domain, and solution data models. Now is the time to do some data modeling. We have a library of industry standard data models that can be used as templates or starting points, and here we will use the APM data model from the library. Some of these industry standard models are very, very large, featuring thousands of different types and tens of thousands of properties each. But the APM model strikes a good balance between size and simplicity. The user can extend these models if new types or properties are needed and the models are versioned. This is what the data model actually looks like. These domain data models allow you to model your fleet of plants globally in a uniform way, regardless of what source system the data originally sits in. This way, apps and use cases scale orders of magnitudes faster. When populating the full asset performance management data model, we need multiple transformations to populate the different types of nodes and edges. These needs to run in a sequence, and CDF gives a way to orchestrate such complex jobs to the Flows UI. Each box here represents a transformation, but could easily also be arbitrary code hosted in Cognite functions, webhooks, or another workflow. Remember how I mentioned that entity matching is like the Swiss Army knife for contextualizing data? We can also apply the same technology to data modeling. Now we find that the data is populated, but some links between different datasets are not explicit in the source system. Cognite Data Fusion's AI-based contextualization learns the connections between different datasets based on a few manual samples. So by entering the power consumption here, it automatically suggests the rest of the links for us. We can adjust the confidence level of the suggestions here and then finally approve the suggested links. Using generative AI, we can translate human semantic queries into GraphQL that industrial knowledge graph can answer. For example, we can ask Cognite Data Fusion to show me all the work orders from October 2019. Or another more complex query like, show me equipment with its work orders and functional locations. The data model is a graph, and it can be explored interactively in the graph viewer. We can double-click on nodes to get a more appropriate view depending on the type of node, such as time series nodes in this particular case. We can also view the results as a table. And now, I'll hand it over to Andrea to delve deeper into how contextualized data combined with generative AI allows industrial experts to solve challenges and rapidly gain actionable insights.
Hello everyone, my name is Andrea and I'm working here in product management at Cognite. During this next segment of our contextualization masterclass, I'll be guiding you through how we can actually leverage our contextualized data and artificial intelligence to generate valuable industrial insights. I'll be focusing on two experiences in particular. First, we'll spend most of our time in the industrial canvas, a brand new digital workspace in Cognite Data Fusion, especially used for data-driven planning, troubleshooting, and collaborative analysis. We'll then build a Python application on top of Cognite Data Fusion without writing a single line of code, entirely using natural language and the power of generative AI. But let's get started. What is industrial canvas? This first of its kind experience for industry allows experts to actually go from cumbersome manual workflows to a visual collaborative interface powered by contextualized data and artificial intelligence. While old legacy industrial software might have been restrictive, closed, and siloed, Cognite Data Fusion actually provides a blank canvas for subject matter experts to think creatively, to build and work with industrial data from all sources. Now let's go through a live demonstration of the new product experience. We have already created a digital twin, or industrial knowledge graph, if you will, that contains sensor data, equipment metadata, work orders, 3D CAD models, and interactive piping and instrumentation diagrams. But now let's take the role as process engineer. So it's time to actually put this data to use in investigating a performance issue on a heat exchanger.
So I can just
Our investigation starts with the engineering drawing, which is key to actually understand what other data is relevant to this particular equipment. So I can just very easily look for my drawing. And here I have the engineering drawing in my canvas. I can very quickly summarize this document. And usually a process engineer works with several documents, which can be a very large document. So having a very handy way of summarizing documents is very useful. So now each highlighting area on the PNID, it's clickable and can be used to fetch additional data to the canvas. So now we're just following links in the industrial knowledge graph. The 3D web viewer we just opened now, it's called Reveal, and this reusable component that Cognite has open source and that is embedded into many dozen different applications. It allows high performance streaming of very large 3D models and point clouds, even on low power devices. Even in this canvas, we can see that it's fully interactive. We can also open the sensor data related to each node right here in the canvas to get a more and a better good situational awareness across the different relevant data types. This is also a reusable component. I can zoom in and zoom out. I can change the time range. And I can see that something has happened and pressure has dropped, so I really want to investigate this and understand what is happening. We may want to go further upstream or downstream than a single diagram can show, and we can take advantage of the contextual links to similar diagrams which are connected to this one. So I can very quickly visualize diagrams that are connected with the one that I selected in my canvas. But the heat exchanger is our current example, but it applies to any root cause analysis or troubleshooting that users want to create. That is what data democratization looks like, bringing the data consumption experience to the human user level. But now going back to the heat exchanger, we find the temperature sensor upstream. That might be of interest to our investigation and add that as well. And of course, the metadata of each node can also be brought in. And of course, now you can always see the source structure and full details of data in the Data Explorer just by clicking Open in Data Explorer. Now we have gathered some relevant time series, engineering diagrams, and the location of the equipment in 3D. We can also look at the related files on this equipment to see if there are any relevant images from a recent, perhaps, operator round or robotic inspection to get an up-to-date, real-world view of the equipment. We can easily add this visual data alongside the rest. Finally, let's clean up our work. We can also add some visual elements to organize our canvas and make it easier for our colleagues to pick it up where I left off. We have access to different shapes, lines, and of course, sticky notes and comments to ping people directly. And to share this with my colleagues, all I have to do is copy Canvas link, and I can very easily share it with my colleagues. Now let's just take a minute to reflect. As you can see, we are looking at all sorts of data from several different sources in a single view. There's never been anything like this available to industrial professionals, and it's all thanks to the power of contextualization. This is all we have the time to show in today's masterclass. If you haven't already, I would encourage you to sign up for Cognite Hub and reach out to us with any questions, feedback, and if you'd like to schedule a personalized deep dive session. With the recent revolution in generative AI, low code is finally being made to work for business end users with little or no programming experience. As Guy already presented, industrial data in its siloed form fails to unlock today's business opportunities. Manual workflows need to be replaced by those that are automatic and augmented by AI. Imagine the value potential of giving every single subject matter expert in the industry the ability to create Python applications as easily as they can write a sentence on their keyboard. Providing both simple access to the data but also the tools to apply their domain expertise in a user-friendly way will be a catalyst for true industrial transformation. With the recent evolution in generative AI, low-code is finally being made to work for business end users with little or no programming experience. So with this Copilot, I can create now mini applications that do useful work by describing what I want in natural language. Here, I build an app for editing some metadata about assets. So I can search for an asset and then change its description. Of course, if I have the right level of access. This is a great example of end users enriching the data. The only way to reach data quality fit for purpose is to actually expose the data to the end users, allow them to give feedback and iterate. I simply tell the Copilot what I want and it generates an app for me. I want to generate a new Streamlit app, create an app called Edit Asset, where I can search for assets, select an asset from the results, and edit the description of that asset, and finally, store it. The app runs interactively in the UI, and any changes are reflected instantly. So you can see that I'm in fact able to search, select, and modify an asset here. The reason we can apply AI this fast is that the robust industrial data ops foundation is right in place. The possibilities for using data in new ways for the business end users are just endless. Now we can double check that our asset is in fact updated and modified by going back into the Data Explorer. And yes, we can see here that it's been modified. Thank you, Gary and Pete, for taking us through those valuable explanations and tutorials. And thank you all for joining us live or on demand for this Data Contextualization Masterclass. We hope you are getting more knowledge now and more eager to actually drive contextualization initiatives in your day-to-day work. As this product tour comes to a close, we'd like to draw your attention to select resources that you may be interested in. Once again, questions and follow-up discussions are always welcome at any time on our fully open user community Cognite Hub, available at hubcognite.com. If you are interested in learning more about Cognite AI, I would encourage you to read the inspiring open letter written by our CEO Girish Rishi, where he shares insights into the transformative power of generative AI, its implication for industry, and how Cognite is harnessing generative AI to bridge the gap between complex computing code and understandable human language. And last but not least, if you enjoyed our segment on the industrial canvas, be sure to stay tuned for our next product tour after the summer, which will feature a deeper dive into this exciting new technology and many more. Thank you for joining us, and we look forward to engaging with you again very soon.